we're going to talk a little bit more about sending data really on the client side. So writing your generic client, we'll complete that generic client and how it sends data, receives data. Okay, so still making our generic client. Say we've created our socket. Okay, we've called it MySock. We've created our socket. Now, what you need to do next in your generic client is you have to connect your socket to the remote socket, to the server, right? Now that we've created it. So you need some host to connect to, right? You need to know the host address. So the first line of code is saying host equals, it's setting the host. Now, generally with these hosts, you as a human are going to know the domain name, but you won't know the IP address, right? Probably. So let's assume that you have the domain name, but you need the IP address. So the host is IP address, but you only have the domain. So what are you going to do? You're going to call this function socket.getHostByName, and that performs a DNS lookup. So you call, if you look at that line of code, socket.getHostByName, and the argument is the domain name, www.google.com, or whatever domain we want to communicate with. So you call that, and it returns the host, which is going to be its actual IP address. Now, once you got the host, you can connect to that host. That's the remote host, so you can connect to that host. Now, we call this connect, mysock.connect. MySock is the socket that I've created. So mysock.connect, that function creates a connection to a remote host, a socket, presumably a socket on the receiving end, on the host end. Now, notice that if you're connecting to a remote host, you got to give the host the IP address, but you've also, as the next argument is 80, that's the port number, because remember that these sockets are associated with the IP address, the host, and the port number. So when you make a connection, you got to specify the port number, that's the next argument. Port 80 is connected with web traffic. So what we're trying to do with this connection is we're connecting to this web server that's at www.google.com. So mysock.connect, it establishes the connection between MySock, the socket on the client side, and this listening socket on the server side, listening on port 80. Now, once we've made that connection, we're going to want to send some data on that connection. Now, in this case, we're talking to a web server. So if you're talking to a web server, it's expecting a request formatted in HTTP format. Now, we haven't talked in detail about HTTP format, but I'll tell you that if you look at the first line, message equals get, that line right there, that is your most generic GET request. We don't have to go into the details of the protocol because that would take a long time. But generally, when you the most generic type, the first type of request that you can make is a GET request, and all we're asking for in that request is we're just asking for the web page, right? Google.com, www.google.com. We're asking for the contents of its web page so that we can display it locally on the client. So get, you give a slash as the next argument. Slash is basically saying which slash is basically the path. So we're just looking for whatever is at its top level path, just slash. And then you say HTTP 1.1 because that's the version, and then you got /r/n, carriage returns, and line feeds. So a couple of carriage return line feeds. But that is your most generic GET request right there. So that message is actually an HTTP request message asking for the web page, the contents of the web page. So we make that message string, and then we send it. So we call this mysock.sendAll, and we pass it the message as the argument. So sendAll sends all the data. It just takes whatever the message is and sends it to the server. And sendAll tries until it succeeds. There's also a send method. So we use sendAll. sendAll tries until it sends everything and until it succeeds. So we're using the sendAll method. So this actually sends the data to the server. Now, once the data is sent to the server, your client is going to want to wait until it receives a response, right? So in this case, we requested the web page. We want to wait until we get the web page, right? We want to receive the actual contents of the web page so that we can do something with it, like draw it on the screen or search through it or whatever it is. So what I call to receive the data is I call the receive function, RECV. Now, mysock.receive. Now, notice that it's taking one argument, 1000. That argument is the maximum amount of bytes that I want to receive. Now, 1,000 might be too small, but I have that limit there. The reason why you have that limit is actually this is more important for a language like C. Normally, that limit is there because this data that's being received is getting copied into some buffer. Okay, data is the name of our buffer here, right? Now, in Python, you don't have to specify the size of that buffer, and Python will, as a programming language, will size that buffer according to how much data comes in. So it will resize it. If more data comes in, it'll make it bigger. Right? If you're programming in a language like C, then that buffer you have to specify. You have to declare, I want my data buffer to be size 1,000. Okay, let's say I did that. Then, if that were the case and I had a fixed size buffer, then I have to be able to control how much data is coming in. Because if I receive 2,000 bytes of data into a buffer size 1,000, then I've got a problem called a buffer overflow, and that's a security issue. So that's why, as an argument to the receive function, you pass this number that is the limit on the amount of data that you want to receive. It actually is not so critical with Python because Python will just resize the data buffer for you. And this receive function, or method, it's a blocking wait, right? By default, it's blocking. So what that means is that it'll sit there, the client will sit there and not do anything until it receives the response. Now you can change that, make it non-blocking. We will not do that. Right now we're just going to assume the most generic blocking. You wait there until you receive the data. So that's how you receive data. Now once you've received the data, maybe you print it or something like that. Doesn't matter what you do. Say you print it. And then you close the socket, right? And you're done. So all you do is call mysock.close, and that will close the socket. Now closing a socket is important to free up the port. You see, once you've opened up a socket on a particular port, port 80 in this case, no other process that's running on your machine can use that port until you're done with it. Right? So you close the socket, and that allows, maybe there's another process that wants to use that port, and now they can after you've done the close. Thank you.